Central Pacific Railway, begun by teams from both the Atlantic and Pacific coasts, was joined in 1869 near Great Salt Lake in Utah, a triumph of engineering over the vast new continent. Atlantic and Pacific, joined by the Iron Horse. The consequences of boldly defying nature are now better understood. The new causeway stops fresh water reaching half the lake, so it's getting saltier. Our ability to transform the landscape leaps ahead with our technology. The Bingham copper mine has turned a mountain into a crater over half a mile deep. But other kinds of craters, volcanic cinder cones, are scattered across the land called the Great Basin, and scientists are beginning to realize that it is the changing nature of the continent itself that threatens or smiles on our endeavors, that our future as well as the past depends on the making of the continent, which floats uneasily above the fiery molten heart of the earth. This program reveals how the North American continent is even now being torn apart, how mountains are being formed, and how even our cities can be threatened by the fiery magma below the Earth's crust. But first it helps to understand the immense scale of the forces involved. The story begins deep beneath the oceans. Underwater eruptions are continuously forming new crust for the Earth, as the ocean floor spreads apart a few inches every year. These eruptions occur on mid-ocean ridges beneath the Pacific and the Atlantic. The sea floor moves outwards from these spreading centers, and as it does so, the continents, including North America, drift across the globe. On the west coast, the American continent meets ocean floor, spreading from centers beneath the Pacific. The sea floor descends beneath the continental crust or plate. The continent is built of rocks lighter than those of the ocean floor, so it floats on top. Normally, the ocean plate sinks at a steep angle into the molten heart of the Earth. As it descends, it gets hotter, and the water it contains acts as a flux. This lowers the melting point of the continental rock above, and huge dome-shaped masses of molten rock are formed. These plutons rise slowly to the surface because they are hotter and therefore lighter than the rock which they push aside. If this molten magma reaches the surface, it causes violent volcanic eruptions. This is what happened on the western edge of North America 100 million years ago. It seems improbable, but you can actually see the plutons exposed by erosion at Yosemite and the Sierra Nevada of California. Once they were buried a mile deep, where they cooled to become granite. The domes can be as much as a mile or even tens of miles across. "60 million years ago, the coastal mountains had eroded, the Atlantic was widening rapidly, and the North American continent was drifting fast to the west. It rode over the Pacific plate so quickly that this ocean plate did not have time to sink down into the mantle. Instead, it scraped close below the continental plate. The friction crumpled and shortened the continent to form the Rocky Mountain Range. This went on for about 20 million years. The Rockies form the Continental Divide, and also a boundary between the stable continent to the east and the changing continent to the west. As the Rockies formed, the consequences for life were dramatic. Large lakes were trapped in what is now Colorado and Utah as the mountains spread inland. They had a semi-tropical climate. As the Rockies rose further, material eroded from the mountain slopes filled up the lakes. Then, with the Colorado Plateau, they were lifted 1.25 miles upwards, trapping the life of the water in stone. These are oil shales. Within them are imprisoned not just petroleum, but fossils of the whole complex variety of life that once lived in the lakes. This school of little fish probably died when a change in the weather upset the oxygen balance of the water. The fine grain of the stone means that these are some of the most detailed fossils in the world. This fish died in the act of eating another. A freshwater ray. A palm, the sign of a warm climate. Even insects are preserved. A flea. And this is the skeleton of a marsh bird. Then came another great change. The American continent now moved more slowly towards the west. The Pacific plate peeled away beneath it. The land above stretched, and huge eruptions of basalt lava flooded out over the surface, some up to 1/2 mile thick. Then the crust sagged downwards to form the Great Basin. No longer could rivers escape to the sea. These colossal interactions between the plates of the Earth's crust underlie the strange character of Utah and Nevada, the cause of the Great Salt Lake, salt flats, and desert. Great Salt Lake is on average only about 35 feet deep and 5 times saltier than the sea. The wind blows trails of salt froth across its surface. The next fundamental change to shape this part of Western America began about 15 million years ago, when the Pacific seafloor plate was sliding northwards past the continent. As it did so, it dragged the edge of the continent with it, twisting and stretching the Great Basin to form parallel ranges of mountains. The brittle crust of the continent sagged as it was stretched. As the blocks of mountains sank, they tilted, and the crust became thinner. Erosion softened the edges, but the structure remains. That's why rows of parallel mountains stretch across the area that geologists call the Basin and Range. High ranges capture snow in winter, but the valleys are sagebrush and desert, one of the most remote and unpopulated areas in the United States. But its turbulent geological history was to lure miners into even its most hostile corners. To the pioneers, it was an unfriendly land. To the west, on the horizon, stands the wall of the Sierra Nevada, which was such a barrier to their wagons. The great parallel ranges tower over gentle valleys like the crests of waves 20 miles apart. Because there is so little rainfall, the gravel eroded from the mountains does not travel far. Each valley basin is gently curved. Beneath the valleys, the crust of the continent is only 20 miles thick, the thinnest continental crust in the world, and it's still stretching. The mountains are rising 1 foot every 500 years. With such a history, it is no surprise to find recent volcanoes. The Great Basin is bounded to the northeast by an extraordinary feature. The parallel ranges suddenly give way to the flat expanse of the Snake River Plain. This, in turn, ends at Yellowstone, famous for its geysers. Geysers like Old Faithful are evidence of hot magma close beneath the surface, and the heat flowing up through the ground is much more than normal. Groundwater is heated by the magma and seeps upwards to erupt as steam. Hot waterfalls draped with stalactites, and miniature terraces are built from silicates and carbonates dissolved in the superheated water before it reaches the surface. In the center of the park lies a depression partly filled with a large lake. This provides evidence of Yellowstone's dramatic origin. It is a vast oval depression where a volcano collapsed to form a caldera. It was caused by a colossal eruption 600,000 years ago. The caldera was created when a mass of magma about 40 miles across moved slowly towards the surface, causing the rock above to bulge and crack. Eventually, the fractures reached down to the magma and released the enormous pressure of dissolved gases in a huge eruption. 175 cubic miles of molten rock buried the surrounding landscape, traveling at 100 miles an hour. Then the ground collapsed, half a mile deep into the top of the magma chamber. The final stage happened when a different kind of lava, rhyolite, erupted through the rings of cracks across the caldera floor, and the center began to bulge again. The yellowish rhyolite gives Yellowstone its name. The Yellowstone River has since cut out a gorge deep into the rhyolite lava of several different eruptions. Some of the rhyolite flows are softer and erode more quickly than others, causing a series of spectacular waterfalls. Hexagonal columns of basalt were formed in a stationary lava flow at the time of an earlier eruption and were covered by gravel when the river flowed over them. High above stands another layer of basalt, another lava flow. More evidence of the continuous history of eruptions in the area are fossil trees which were buried in volcanic ash. As one forest was buried, another grew on top until there are no fewer than 27 different successive layers of fossil trees. It is now believed that the recurring eruptions in the last 2 million years at Yellowstone have been caused by a hot spot beneath the surface of the continent. It is extraordinary, but this hot spot appears to have burnt a trail across the continent as it drifted 2 inches a year. The track of this hot spot is the level Snake River Plain in Idaho. Volcanoes such as these, called the craters of the moon, have erupted within the last 2,000 years. The lava that flows from them spreads out in thin sheets across the level plain. After the movements of the continental plate and the eruption of volcanoes, the greatest force to shape the landscape and its life has been ice. The great ice sheets of the ice ages did not reach the Snake River Plain, but they did cover 2/3 of North America, including New York and Missouri. Vast ice caps covered mountains as far south as New Mexico. The climate became much wetter, and the rivers filled huge landlocked lakes throughout the west. Lake Bonneville, the largest, covered an area of 21,000 square miles. As the ice advanced and retreated, the lake's level rose and fell. Waves caused these horizontal shorelines. About 15,000 years ago, the lake was about 1,000 feet deeper than the present Great Salt Lake. It was held in place by a natural dam of sand and gravel at Red Rock Pass, and looked like this. Then the lake spilled over. The stream became a flood and washed away the natural dam, and the lake disappeared. 380 cubic miles of water swept in a catastrophic flood across the Snake River Plain. It surged down the canyon of the Snake River, completely filling it for 6 weeks. The water rushed to the Pacific at the rate of half a cubic mile an hour. Boulders the size of houses tumbled before it. It was one of the worst floods the world has ever seen. The rest of the lake continued to evaporate, and now forms the huge expanse of the Bonneville Salt Flat to the west of Great Salt Lake, flat enough for racing cars to challenge the world speed record. At the time of the Bonneville flood, this was a land of cool forests inhabited by giant animals, many of which had arrived in America during the Ice Ages, crossing the Bering Land Bridge. But the climate has since undergone a great change. Now, their bones lie in a desert.
This way down, the only thing is holding those two bones that are loose, so we can sort of bomb this whole thing out and the other one is loose.
These are the bones of a mammoth.
So this area here, you can start just cutting back. Yeah, I think. Well, you could take this whole area down to where he's standing.
Why so many animals like the mammoth became extinct is not at all clear, but it is known that the animals alive then were very different. Giant sloths, saber-toothed tigers, mastodons, American camels, giant lions, and huge condors, even an American horse, bison with horns 13 feet across, all went the same way as the mammoth. By about 10,000 years ago, all had become extinct. One factor was certainly the arrival of man. He reached Alaska via the Bering Land Bridge from Asia at least 27,000 years ago, and it's possible that he killed off all the mammoths. If so, it must have been a formidable task. It's hard to prove. The presence next to bones of stone tools may only mean that men took advantage of a carcass already dead. The largest animals recently hunted by the Indians were buffalo and elk, but they survived in large numbers until the coming of the rifle. What is more probable is that the geology and the changing climate killed the cold-adapted animals. As the ice retreated, the summers grew hotter and the winters colder, while the Great Barrier to the west, the Sierra Nevada, cast a rain shadow, a drought across the Great Basin. Right up until the last 2 winters, the glaciers on its peaks were retreating. As summer succeeded summer, the deserts moved north. With the dunes came very different animals, adapted to survive in them, such as the fringe-toed lizard. It burrows to escape the heat. It even breathes with its chest moving up and down. Its sides are rigid. Otherwise, the weight of the loose sand would suffocate it. It has a tightly closing jaw. Its eyes have special lids, and its ears, covers. All adaptations to keep out the sand. To help it dig and travel over the surface, it also has fringes on its toes. Many desert-adapted animals are only active at night or when the sun is low. One such is the sidewinder. Its curious method of locomotion helps it to keep its body clear of the hot sand and enables it to move fast across open country. Few areas of the continent have changed so much so recently as Death Valley. It got its name from a party of pioneers who became lost there on the way to California and narrowly escaped death from starvation. During the Ice Age, it contained a great lake called Lake Manly. As the lake dried up, its salts collected until they were left crystallized on the floor of the valley. The bottom is below sea level. Death Valley is one of the hottest places on Earth. Yet in the middle, where water trickles to the surface at Cotton Ball Marsh, you can find fish. This tiny pupfish must be one of the most adaptable fish in the world, able to survive in water at nearly the freezing point and at the temperature of a hot bath, and in water 3 times as salty as the sea. This little school inhabits a small pool, which is all that remains of a huge system of lakes and rivers that their ancestors used to travel from valley to valley. The only stream now dries up in the hostile desert. Another island in this sea of desert is Big Spring in the Amargosa Valley. The pupfish isolated here have evolved in different conditions and are now a different species. The pupfish to be isolated longest in their own tiny habitat, and so the ones least like all others are those at Devil's Hole. This incredibly clear pool, deep in a limestone cleft, is only 60 feet long. Here, the Devil's Hole pupfish, one of the rarest animals in the world, feeds, breeds, and rears its young on a shallow rocky platform only a few feet square. Fish in a desert. They have survived here for several thousand years. The lake which brought them here has disappeared completely. Just as the islands of water in the desert have isolated the pupfish, so the ranges of mountains in the Great Basin have isolated other plants and animals on their peaks. High above the sagebrush and the forests is a bleak alpine zone, cold and dry. On these peaks live yellow-bellied marmots that are starting to evolve into different species on the different ranges. In the short summer season, they creep out into the sun, sheltering from the bitterly cold wind. They hibernate to escape the snow. But in summer, the valley bottoms are now too hot for them to cross. The same is happening to the golden-mantled ground squirrel. The ground squirrel is adapted to live in surroundings which now exist only at the tops of the ranges. It can't cross the semi-desert of the valleys between. Forests of some of the most remarkable trees in the world are also isolated on limestone slopes at about 12,000 feet on the peaks of the basin and range. They cling to life with thin strips of bark, so tenaciously that some are over 4,000 years old. Bristlecone pines. Some were saplings when men were building Stonehenge. What will the world be like when this tree has grown full size? The depths of the basins, like the Bonneville salt flats, are now too salty for vegetation. But when the lake was at its highest level, it was much deeper, and high above the present shoreline in the cliffs, it carved caves. After the dam at Red Rock Pass gave way, the shores had more vegetation, and 11,000 years ago, Danger Cave was one of many used for shelter by wandering hunters. It was still the lie of the land which determined how the Indians could live. They traveled to the lakes to hunt the huge flocks of migrating birds. To catch them, they made decoys. It's quite clearly a good imitation of a canvasback duck. And this, a Canada goose. Both are from Lovelock Cave in Nevada. The decoys were made of tule reeds and are about 1,000 years old. In the Owens Valley, hut circles were built for permanent villages. Their inhabitants had to rely on wild grasses for grain to pound into flour in their stone mortars. The rain shadow of the Sierra Nevada prevented the summer rains that could sustain crops. But the volcanic history of the area did provide one important bonus. Obsidian, black volcanic glass. It fractures naturally with extremely sharp edges, and the Indians became so expert at shaping it that some ceremonial blades were over 3 feet long. Spears were used first, then much later, bows and arrows. A skilled worker can make a point like this in half an hour. Petroglyphs decorate favorite ambush sites on the migration route of deer and bighorn. In the late summer, the men would follow the animals high into the mountains and conceal themselves in blinds built into the rocky outcrops. Some of these still exist today, at least 1,500 years old. Beneath the blinds still lie the broken spear points which missed their targets. About 1,000 years ago, summer villages had to be built high in the White Mountains, where the Indians could find more food for the fast-growing population. Whole families lived here. The deer, which they hunted with arrows, still pass this way, leaving tracks on the deserted floors of the huts themselves. At the sites, evidence of other food, roots and pinyon pine nuts, the most important food source of the mountains. Pinyon pine forest is a comparatively recent arrival to the Great Basin area. The trees moved north and spread across the ranges about the time the Indians first arrived. The heavy seeds are distributed by birds like the Clark's nutcracker and the pinyon jay. Thus, the tree could become established across the dry valleys without difficulty. The pinyon pines, more than any other food source, allowed tribes like the Paiute and the Washoe to survive on the edge of the desert. These are Washoe tribespeople. Each crop of pine nuts takes 2 years to mature, so the tribe can plan in advance where to travel to get the best harvest, but only within their traditional territory, which may cover a very large area. It's a very sticky occupation, as the cones are covered in resin. The pine nuts are toasted with hot charcoal. To avoid burning a hole in her basket, Joanne Martinez must keep them moving. When they are cooked, the husks can be cracked off. Then, Teresa Jackson winnows them. Altogether, it is an extremely laborious process to collect and prepare enough to feed a family. But then it never was an easy life to survive on the meager natural resources of the basin and range. The nuts have yet to be cooked a second time, and often were pounded to a flour. They taste delicious. Before the arrival of white men, small bands of nomadic Shoshone Indians survived even in Death Valley, trapping small animals, digging roots, and catching the little pupfish. To the pioneers heading west, the Great Basin with its rivers which turned yellow and died, its alkali flats and endless miles of emptiness, was a place to be crossed with all possible speed. But to miners, its geology held the promise of silver and gold. Even the glaring flats of Death Valley yielded borax, used for making soap. These rectangles are rows of borax heaped by Chinese coolies 100 years ago. For 5 years, borax was hauled by the famous 20-mule team 162 miles to the nearest railway. The wagons carried 12 tons each. Silver and gold mines and their towns sprang up almost overnight, built on a tide of speculation. Then, as now, it was those who mined the miners who got rich. But as quickly as the towns sprang up, they died. This bank at Rhyolite was completed in 1908. Within 2 years, it went broke. The gold ran out, and a town with 2 railways, 3 newspapers, and 20 saloons returned to the desert. The silver of Virginia City, of Austin and Belmont, the gold of Bullfrog, these were the magnets that drew miners to Nevada. For a few brief years, they brought the trappings of comfort and style to the wilderness. The Cosmopolitan Hotel once served quail in aspic with champagne, paid for with the precious metals which were found in the mountains, the rich veins that had been formed with the continent by volcanic activity as the Great Basin stretched and the ranges rose. In 1879, Bodie had 30 mines and 65 saloons. A preacher called it a sea of sin, lashed by the tempests of lust and passion. The mule train gave way to the railway, the automobile, the sagebrush. The prospectors abandoned or lost their burrows. They have outlived both the mines and the miners, and are changing the landscape in their own way. Adapted to live in the deserts of Africa and able to survive for days without water, they thrive on the steep desert mountains. Now there are 3,000, even in Death Valley. But their success has been at the expense of the native desert bighorn sheep, whose fodder they eat. Because the burros will eat almost anything, they are making the desert worse. On the open valleys, where there is enough moisture for grass, other accidental newcomers are changing the land. Wild horses, or mustangs, descended from those first brought by the Spanish conquistadors, who came seeking gold. The Indians of the Great Basin never learned to ride horses. They ate them instead. Now the horses are multiplying and are overgrazing the grasslands. In the summer, the wild horses congregate at the rare waterholes, frightening away the native pronghorn or antelope. Pronghorns look remarkably like African gazelles, which is not surprising, as they are related, having crossed via a land bridge from Europe some 30 million years ago. In North America, they once roamed from cold tundra to hot desert, because they then had few competitors. Now they are on the run from the rifle and from progress. One of the reasons that the mines of the Great Basin had such a short life was that the quantities of high-grade ore were small. They soon became uneconomic where mining costs were so high. But in 1906, at Bingham Canyon in Utah, the first large-scale open-pit mine was begun. The ore contained just 2% copper, and it was ridiculed by miners of the day. Now, it is called the richest hole in the world, as well as the biggest, nearly 2.5 miles across. Half a million tons of rock are removed every day. 4 tons of waste have to be moved to reach every ton of ore. Each ton of ore now contains only 12 pounds of copper, but every truck holds 150 tons. They're enormous. So enormous is the scale of this mine that it has earned 8 times as much as all the gold rushes of North America put together. The copper is cast into anodes for electrolytic refining. The profitability of the entire enterprise depends on the price this copper brings. The payroll alone comes to $65 million a year. Apart from the mines, this austere but strangely beautiful land is of very limited use to man. 86% of Nevada is still owned by the U.S. government. The pioneers passed it by. The sagebrush itself is almost valueless. Cattle will seldom eat it. The ranches are on an heroic scale. Wayne Hage drives his horse to work in a trailer. He ranches 1,100 square miles, about 750,000 acres. The unfenced boundaries, perhaps one should say frontiers, are the peaks of the Monitor and the Toquima ranges. Along the valley, the ranch stretches about 80 miles, so a roundup can take days. But the land is so poor that on average, every steer needs 200 acres. The valleys, landlocked basins, are salt and dry. The main factor that makes the basin valleys so unproductive is the lack of water. In summer, water becomes a vital necessity, and water rights are a bitterly contested issue. Many natural wetlands, like those at Ash Meadows in the Amargosa Valley, have recently been exploited, with catastrophic effects on rare plants and animals. 20,000 homes were to be built at Crystal Pool. Several unique plants and animals had become extinct. Then one developer died of a heart attack. Now, remaining rare species may be saved. The water level in Devil's Hole itself began to fall, threatening the pupfish because of ranchers pumping water nearby. It took a decision by the Supreme Court to protect the water in what was already a national park. Now, even to see the fish, you need an appointment. In the West, people shoot at signs anyway. But how disinterested was this marksman? The pupfish of Big Spring were affected by a weapon of a rather greater magnitude. This strange billowing sand at the bottom of the pool began when the first atom bomb was exploded on the Nevada test range 30 miles away, and the bottom of the pool caved in. Because so few people live there, the Great Basin contains large areas set aside for atomic and military test grounds. The population is mostly concentrated at the two edges, where water runs off the Sierra Nevada and Wasatch Mountains. But these areas are geologically dangerous. Over 80% of the population of Utah lives within 12.5 miles of the Wasatch Fault Line, which is still pushing the Wasatch Mountains into the air. There has not been a big earthquake for 133 years, and one of the fault segments may now be due to break. The history of the Mormon settlements at the foot of the Wasatch Mountains is so recent that historical records cannot help. But it is at least likely that a magnitude 7.5 earthquake could happen soon. If so, it could devastate a large area of Salt Lake City, here, or Provo, or one of the other Mormon cities. Ironically, it was the faults that raised the mountains, which in turn provided the water which allowed the cities to be there in the first place, but nobody knew at the time. On the western side of the Great Basin, the Owens Valley lies between the White Mountains in the foreground and the Sierra Nevada. This region is also extremely active geologically. The Sierra has risen 3,000 feet in the last 3 million years, a very young range of mountains. Below the highest peaks of the conterminous states run two dark fault lines. The Owens Valley is dropping as the mountains are rising. A fault has split a basalt lava flow so deeply that the snow which falls to the bottom in winter never melts. Such rifts seem acts of random violence, but they are part of an overall pattern. Geologists know that a series of large earthquakes have occurred recently about every 30 years along a particular line. In the center is the White Mountain Gap. Where there is a gap in such an active fault system, you can expect an earthquake. It could be due now. The last one on the line was 29 years ago. The potential shock areas cover the Owens Valley, from Bishop, through Mammoth Lakes, and across the Excelsior Mountains to Luning. There have been many moderate tremors in these areas recently, but no big quakes. Hawthorne is almost on the gap and right on another fault system. It is one of the biggest ammunition dumps in the whole nation. Here, the U.S. Army has 10 million square feet of storage in underground bunkers for conventional weapons such as bombs, rockets, shells, naval ammunition, primers, and detonators. It was slightly damaged by the last earthquake, which was 50 miles away in 1954. Let's hope it's ready for this one. The shock could be 30 times as great as the recent earthquake in California, which flattened Coalinga. The Owens Valley has, on average, at least one volcanic eruption every 100 years. The last one was here at Mono Craters 75 years ago. These volcanoes may form part of a future caldera like Yellowstone. The cones extend from south of Mono Lake to Nedget Island, which erupted in 1540. Further to the south, a relief map clearly shows the outline of the ancient Long Valley caldera. At this point, it's worth taking note of what a caldera eruption can do. The tranquil circular Crater Lake in Oregon was once a sleeping volcano called Mount Mazama. 7,000 years ago, it blew up. The explosion ejected 10 cubic miles of ash. On a map of Western America, it looked like this. It was blown east by the wind. Mount St. Helens in 1980 ejected only a quarter of a cubic mile, but the consequences were shocking. The eruption began with an earthquake, which caused an avalanche on the northern side. Before it was over, the top quarter of a mile of the mountain had disappeared. It was converted into a plume of ash 12 miles high, and a devastating incandescent blast of molten rock and ash at 1,200 degrees Fahrenheit. This flattened 200 square miles of forest, leaving huge trees scattered like matchsticks 17 miles away. 61 people died in a mostly uninhabited area. When the Long Valley caldera erupted 700,000 years ago, it ejected 600 times as much ash as Mount St. Helens. The ash plume may have looked like this. Nothing so fearful has happened anywhere on Earth in historic times. But on a geological timescale, caldera-forming eruptions are fairly common, and they can reoccur in the same place. A week after Mount St. Helens erupted, the Long Valley caldera was shaken by 4 magnitude 6 earthquakes. New fumaroles appeared later. The caldera was coming out of its sleep. The whole region of the edge of the Great Basin has been shaken by tremors. Since 1978, there have been 20 times as many as before. At the same time, the highway across the caldera has bulged a foot into the air and is still rising. An official notice of potential volcanic hazard has been issued by the U.S. Geological Survey because it's believed that magma lies only 3 miles below the surface. The epicenter of continuing small earthquakes is close to the small resort of Mammoth Lakes. During the skiing season, there can be 35,000 people staying in the town. Some of its residents object to the official warning. Geologists have now described what they believe to be the most likely kind of eruption, which could occur at the site of the earthquakes. Based on recent eruptions in the Owens Valley, they warn that it could explode, sending flows of incandescent rock and gas 12 miles from the crater at 90 miles an hour. Later, the ashfall could be ankle-deep 22 miles downwind of the possible crater. Paiute Indians call the Owens Valley the Burnt Land. They know its dangers, and they believe that one day the sleeping mountains will awake and drive the white men from their land. Geologists say it's possible nothing may happen at Mammoth Lakes, but they are disturbed that the whole region has suddenly become seismically active. Here, the geology is very different from Mount St. Helens. But although this volcano's eruption was more predictable, the scale of the blast took even the geologists by surprise.